start the recording? All right. And Rachel, you can hear us. Wonderful. Thank you. Rachel, since you just joined us, I indicated that if you have any questions, you can ask them through the presentation just by simply raising your hand and using the icon on the bottom left-hand corner of the participants window. And then Anita Lindemann is going to ask that you type in your question in the chat area. Okay? So I'm going to let Betty start. Betty Lawrence.
Hello. Can you people hear me? I assume. Okay, great. I'm Betty Lawrence. I'm going to switch over to the next slide, so you can see a visual of me if you've not met me before. And I've been with the college for a fair number of years. I won't say how many. But I've been an area coordinator with CDL for a little over 10 years. And my primary area is mathematics, but I'm not going to be talking just about mathematics degrees, although I saw a number of people may be interested in that. But I'll be talking first about the general guidelines for science, math, and technology, and then I will talk about some specific areas. I noticed from the questions that were sent in that there is interest in the technology degree, so I will be talking a bit about that. I forget, what's the easiest way to switch slides? Oh, yeah, okay. The first thing I wanted you to do was just to give me some idea of what your stage is in terms of degree program planning. So if you could go and use the poll right now and just select either A, B, or C, D to identify what stage you're at, what your interest is in this session. Yeah, everybody, the A, B, C, and D selection is again down on the bottom part of the participants window, and you can just select one of those letters to indicate where you are. Okay, great. Good. Rachel and Robert, very good. Okay, good. Link-free and... Okay, good. Okay, well, thank you very much. I thought I'd give you an idea of what I'll be covering today. First, I'm going to go over the general guidelines, and people either say SMT, Science, Math, Technology, or SMAT, and to explain why they are as they are. Then I will talk specifically about degrees in information systems and applied math, just as examples, but also because a number of you expressed interest in those. As I said, there was also interest in technology, so I will address that under 3, just talking generally about those, and certainly I'm welcoming questions throughout, and I'll either answer your question right then or make sure I answer it by the end of the session. Thanks, Gregory. The general guidelines in science, math, and technology, they actually were revised recently, not really much for content, but more hopefully to make them more readable. As you've probably seen in other areas of study in Empire State College, they're quite broad areas, and certainly science, math, and technology is a pretty broad area. So one of the challenges of faculty as they develop these is to come up with guidelines that really do address all the possible concentrations in that area. So these statements here are right from the college guidelines, but I am going to try to talk through them, and certainly if you have questions about anything I say, raise your hand and type them in. So first of all, just to talk about what a concentration in science, math, and technology would involve, certainly one possibility is in the natural sciences, such as physics, chemistry, and biology, mathematics, computer science, and also can certainly involve degrees in technology or applied science. Health-related fields I won't talk about significantly because most of those actually do end up, students do them under community home services. But if you have some interest in that, we can certainly discuss that. The college also talks about organizing frameworks for degrees, and I think there's probably, not just in students but in faculty, some confusion about that. I think you'll find many degrees end up being disciplinary, and disciplinary means within a certain discipline, like mathematics, like physics, like biology. Often students will do degrees of interdisciplinary in nature, and actually information systems is a great example of that, because often students find that their particular degree in information systems is a combination of both the technical aspects and the business aspects. A thematic degree would be looking at a particular theme. Something maybe in environmental studies would be a good example of that. And sometimes students do a problem-oriented. It's not extremely common, but if there's a particular problem, maybe sustainability would be a possibility there, or a professional vocational, and in most cases there a student would be getting a bachelor's of professional studies, and those would be for the highly technical degrees. I had a student do something once in aviation management, which is certainly professional vocational oriented. If you have any questions on that, please raise your hand and start typing them in, because I just went through a lot of vocabulary there and language. Okay, the guidelines continue in terms of goals, and if you have questions, even though I've gone on, please just go back and ask them. This was put in because of a concern, probably in all areas, but I think certainly in science, math, and technology there is that concern about currency, and your mentor may have had discussions with you about that. I think we'd all agree that knowledge in this area is rapidly and continually evolving. For example, the use of computer languages, or use of technology for mathematics, or biological methods. So in your developing your degree in science, math, and technology, this is something you want to be aware of, so that with the attainment of your degree, you are establishing an ongoing area of inquiry that you will develop skills so that you continue to explore. Okay, yes, I see a question there. That's a very good question. And independent learning is important here, because you do want to be able to continually learn, and especially in these areas. And that's a really good question about green technology, because I think that's a great example of being able to evolve in your thinking. A lot of the ideas behind green technology have not changed, but the application of technology for quote-unquote green purposes, certainly you need to kind of look at maybe old ideas in new ways. And I also, if you're thinking of developing a degree related to green technology, you'll need foundational studies, which we certainly offer, but you probably also would develop some independent studies, since there isn't much already established in terms of curriculum in that area. And in your independent study, part of what you would be doing is developing an awareness of that field, and also developing a way so that you continue to do inquiry in that area. And this is the continuation of goals. And again, I think what people talk about in terms of any kind of degree is the need to understand the fundamental concepts For example, in a mathematics degree, one fundamental concept is understanding algebra, the language of mathematics. Perhaps in the applied math, understanding basic statistical concepts. So for each area in science, math, technology, there's some fundamental concepts. And then depending on what area you decide upon, there's a progression of study. Again, I guess we'll go to mathematics. You would progress to understanding of calculus, but you also then would understand calculus deals with what are called continuous functions. In computers, you deal with zeros and ones, you deal with discrete math. Then you would progress probably to math modeling, more progression in terms of differential equations. So you can see that there's a foundation in terms of the language, and then there's progression in terms of skills and sophistication. And going to also more modeling, more theoretical approach. Other questions so far? Okay. I'm just debated in terms of this particular slide, and I'm actually going to summarize it in the next slide. But I decided not to just split this all out, so this one's not as readable. But this is actually the rest of the text in terms of the guidelines for science and math degrees, and then I am going to talk about them on the next slide. Great. Oh, great. So you can, if you open up the PowerPoint, you can see it. Oh, okay. Yeah, why don't I deal with that question first before I get to the general guidelines, because that is a very good question. I hopefully haven't been told, you're not even supposed to mention the word engineering. But it is true that engineering is considered a certified area. And only certain colleges are certified to offer engineering degrees. Empire State College is not one of those. So there is a list. I don't even know, I'll have to tell you later. There's a list somewhere of words that are not permitted in concentration titles, and engineering is one of them. Nursing used to be another one. And actually you can only use nursing in the title if you are in our nursing program. If you are interested in an engineering degree, you do need to look very closely at engineering schools. And you even have to be careful about what courses you may take with us, because engineering schools, because of their special certification, have certain things that need to be included in their courses, and they may not accept our courses as transfer courses into their programs. We do, a student can have a degree program in, for example, electrical technology, but they cannot have a program in electrical engineering or any of the engineering areas. So it's a very good question. Glad you asked that, so I could elaborate on that. So if you're interested in engineering, have a conversation with your mentor now, because we are not set up for that. But then again, I have had students, for example, I had this one student in aviation. Students come to us with very strong technical backgrounds and maybe even engineering background, but they don't necessarily want an engineering degree. They want to use their engineering background to move towards some other kind of degree. And there are many titles available depending on your goals, that you can get a very good science, math, and technology degree from Empire State College. But we certainly are not able to address all students' goals in this area. If you have other questions on that, do let me know. I am. This is the bulletizing of the previous list of objectives. So I could just talk about each of them, and you wouldn't have to look at all of that text. So these are the main things that you would need to demonstrate in your science, math, and technology degree. One is really a working knowledge of the vocabulary of the field. I think that's understandable, and an understanding of fundamental principles. Of course, depending on what degree you're going for, these are going to be very different. They're very different for a biology degree, for example, than for an information systems degree. But in both cases, the importance is to have the working knowledge. Then the competencies, again, depending on your area. So if it is something in the laboratory sciences, you certainly need to understand experimental techniques. If it's in the math area, you need to understand statistics, data acquisition. Under the competencies is also the needed mathematics for that degree. So even though these degrees are all under science, math, and technology, the type of mathematics that's appropriate for the degree will differ. Communication skills is considered a competency as well. And again, it may vary. For the sciences, the focus there really is on lab reports. For information systems, it will be more in terms of dealing with case studies, probably more writing there. And then the computer part, understanding computer applications, again, specific to the area. But those are the main competencies. Knowledge of experimental techniques, whatever math is appropriate to the field, communications for the field, and computer applications. The third main bullet is the critical perspective, and this really is in some way connected to what we talked about before, with the lifelong learning, the ability to integrate in different ways. For example, asked earlier about green technology, to be able to look at that area with analytical thinking. And then the fourth main area is the wider context, and often students look at this in like technology and society, maybe a course like Future of Being Human. There are different ways to do that, or you may already have that understanding and you would go for that in terms of credit by evaluation. Okay. Now I mentioned earlier disciplinary areas in which you can get a degree. And there are available separate guidelines, more specific guidelines in the following disciplinary areas. One is information systems, biology, mathematics, computer science, and chemistry, physics, and technology. What we find, though, is that many students in SMT end up doing something a little bit different from the disciplines in terms of their titling. For example, right now there's a disciplinary guideline in mathematics. More students probably go for applied mathematics. We don't have environmental studies down here. Environmental science. We are actually working on that as an area. So these are not the only areas in which you could develop a degree, but if you're looking for something like environmental science, you may want to take a look at the biology one just to give you an idea. But you would not need to follow those guidelines specifically as you develop your degree. Also, these are all under revision, and it has to go through a series of approvals, etc. But I can share with you at least in terms of some of the changes, and I will be sharing you some of the proposed changes for the mathematics, for example. Okay, great. So I'll wait with that question Okay, so Rachel, go ahead and type in your question and, oh, good. Oh, oh, that's a very good question. Unfortunately, not. The general guidelines, if you look on the website, you'll see that the new set are available are for students who matriculate after January '09, and the former ones are before January '09. So if we do come out with different guidelines, there will be an effective date on them. My guess is that they probably will come out in, like, they won't come out all together. We hope to have the mathematics one out by 2011. So no specific year on that one. For the environmental technology, there's talk around the college, and there is a faculty member on reassignment this coming year to look at least the area of environmental studies. I'm not sure we'll offer a large number of courses in environmental technology. They'll probably be more general in terms of environmental studies and maybe some environmental sciences. So if you are interested in that, you would need to set up initially some independent studies in that. Because we don't have a large number of students with that interest, so I don't think our plan is to develop a lot of studies in them. Okay. So I did want to talk, just to give you some idea in terms of how the disciplinary guidelines work. As I said, there are disciplinary guidelines in mathematics, and those do specify for a mathematics degree that you would need real analysis, abstract algebra, and also I looked after I did this slide, linear algebra. So what we find with students who are coming in for degrees in mathematics, that they have many different goals for the degrees. Right now, we have actually developed a course called Thinking Mathematically, which meets educational planning credits, and are in the second term now. And so we are finding that the greatest interest of students, it seems, for a degree in mathematics is that they want to teach mathematics either at the high school or the college level. We have students interested in actuarial science, taking those exams. We do have some students interested in going on to grad school in mathematics. Depending on your goals, you would then decide whether to do a mathematics degree, which would include the theoretical aspect, or an applied math degree. One thing to keep in mind as you decide which kind of degree you want is what's your next step. For those interested in teaching, they will need to go to a master's program in which they get their certification, because as we said with engineering, you also cannot get certified to teach in New York State at Empire State College. But students use the route of going and getting a degree of certification at the master's level. Many of the colleges that provide that program with the certification with the master's are looking for real analysis and abstract algebra in the undergraduate math degree. So therefore, those if you are looking into that, you may very well need a mathematics degree. Some students who are looking to teach in other states and have looked at other programs, other possibilities, for them an applied math degree may be very appropriate. And you will not see real analysis and abstract algebra listed as a CDL course, because we don't have that many students who are interested in it at any one time. But we now do have a faculty member who does a combination of independent study and group study with about 3 students at a time in those subjects. So we are able to offer those subjects as more like independent studies. They are not easy subjects. I'm not going to tell you those are easy. They're extremely theoretical, a lot of doing proofs. So you would want to check to see if you really needed those in your degree before pursuing them. They also can be fun. I mean, there are people who enjoy doing proofs, thinking through mathematics that way. In the math courses that we offer through CDL, because they're of use to students doing degrees in math, but also students doing degrees in technology and information systems, are the applied math courses. And that's one reason why we did the more development in that area. For example, we have differential equations, which is of interest to students in technology as well as mathematics. We have math modeling, which again uses some biology applications, so is of interest to students in broader areas, and therefore you also get richness in the class in terms of varying interests. So as you develop your degree in whatever area, it's very important to look at your goals, to look at if you are considering graduate school, what those requirements are, and then work with your mentor in developing your program. Okay, let's see this. Oh, okay. Oh, okay, very good question. Actually, linear algebra is available because that is also one that has broad application. So we offer several sections of linear algebra, and most terms and at least one section each term. It's actually a quite popular course. For courses like real analysis and abstract algebra, it will not show on your transcript that it was done by way of an independent study. Your transcript does have the contract evaluation, the CE, or we call it the course evaluation, which would identify the books that you used, the activities that you did, and how you did on that particular course. I don't think other institutions or employers would be concerned with that. And for the transfer, what they're most interested in is, what did you actually cover? And one nice thing about our narrative evaluations is that they describe the content very clearly. If you are thinking, though, of just doing some courses with us that you will transfer somewhere else for whatever reason, it's always good to check with that other institution to see if the content that we would cover is content that that they are looking for. And if you are thinking of graduate school, it's always a good idea to go and talk to someone in that particular department and talk to them about what you're covering, and see if you are getting the background that they are expecting when you go into that program. Employers, I think they're mostly interested in whether you have good grades, so they probably won't be looking at that as much. Great question. Okay. These are small print, but mainly because you just need them to refer to later. But these are 3 websites for math-related careers, so it's not necessarily a math degree, but careers that would involve math. The math.org is actually connected with MAA. The Mathematical Association of America is a very nice site. And then the UC Davis one also is general, and then just one very specifically on actuarial. Okay, thanks. Do you want me to keep those up longer? Are you okay? Okay. Okay. No, just HTM. They're typing these out there, so you can have them available that way as well. Okay, great. Okay. I did want to talk a bit about an information systems degree, because I think that also brings out some interesting issues in terms of developing a degree, IS meaning information systems. And information systems was an interesting guideline to write, and in fact it's also turned into an interesting one to revise. The challenge with information systems is that it used to actually be known more as either MIS or CIS, Management Information Systems or Computer Information Systems, and that's because there used to be a lot more of a divide between people in the management area who just were using information systems tools and people more in what was called the computer information systems who were dealing more with the technical aspects or the development aspects. And the professional organization that we refer to in developing this guideline and in the revision have pretty much said that it really is just information systems, that everything's sort of blended together now. It's like communication also is all blended in terms of whether you're using a computer or your phone, or so it's all integrated. And so therefore we talk about information systems degrees. But to show there are certainly different kinds of emphasis that you may have in your degree depending on where you're heading with your degree or what your background is also. So we do talk about degrees within science, math, and technology, within business management, economics, and also an interdisciplinary approach. But no matter what area of study you put your degree under, there is this common core, and that's what's listed here. So computer fundamentals, obvious, now that you certainly need to understand computers in order to have a degree in information systems. There also are the business and management and economics fundamentals, and there's probably some, I know there's discussion among faculty about what that entails, but the guidelines at the moment say that to meet at least the fundamentals under any of the areas of study, you should choose from one or more of the following areas: economics, behavior/management, and/or finance/accounting. In my next slide, but I'll mention it now, if you are doing your degree under business management economics, you would need to meet all of the BM&E expectations for a degree, which will be far more than that. So this is more focusing on the common core for any degree in information systems. So you at least need to show some business understanding. And the reason for that really is because most information systems applications still are out of the business environment. We are seeing, I haven't seen too many students, but certainly there's health information systems. So there are areas that are not really as much BM&E connected that we are seeing, but still, even for those, some business understanding is still thought to be important. Quantitative reasoning is important. Certainly at least statistics, again, because a lot of the applications have to do with data analysis. So that's part of the core. And then there are 3 advanced level expectations in terms of the core. One, the systems analysis and design, because you do need to understand the underlying systems in an information system. Something having to do with information technology. And in many cases that involves networks, but also could involve advanced understanding of programming. And then something advanced level in information systems, and for many students that's database, understanding of databases, but also could be project management. And then again, and note that this actually goes back to the general SMAT guidelines, understand the environment in which one works, just having putting your information systems in context. So that is the Common Core. And then, as I mentioned before, the information systems can fall under BM&E, SMAT, or interdisciplinary. And for BM&E, as I said before, you need to meet the BM&E guidelines. For SMAT, what many people may find to be the deciding factor is that for SMAT you need advanced level mathematics. In most cases that's discrete mathematics. And that's for this because it is a degree under SMAT. There is a higher expectation in terms of the mathematical aspects. The guidelines then, I won't go into any details, but you should take a look, talk about the different directions then you can go in depending on what area, and I won't do the BM&E ones, but under SMAT, taking maybe a number of courses in maybe programming, networks, web design, databases. So to make that full 45 advanced level credits, you probably do want to do a cluster of courses that give you more depth in terms of one area. Questions on IS degrees or anything on generally about degrees? And sorry about the size of this. This will be a hard one to retype. Oh, good. There's a hand raised. Good. This is actually the website for ACM, the Association of Computing Machinery, and this is to the 2006 guidelines in information systems, and they are the basis for the revisions that we are working on right now. But it's over 70 pages long, but they probably would be worth at least going and taking a look at online. You don't need to know every detail of it. It's mostly for faculty who are developing curriculum, but that would be important. Okay. Oh, okay. No, that's a good question. Actually, Empire State College just completed its accreditation review with Middle State in the fall, and we got the results back about a month or so ago, and we did get our full 10-year reaccreditation. The only real recommendation made by the team that visited us was that SUNY should give us more money. So they were impressed with how we work with students. That we try very hard to work on student backgrounds, and I think that's what I've been trying to show with these guidelines, that certainly there are some what we feel are reasonable expectations in terms of degrees, but that very much your degree in SMT is dependent on your goals and your research on how your degree will meet your goals. Oh, okay. Oh, okay, very good question. New courses. Well, I mean, we do currently have the intro course in Geographic Information Systems and the advanced course. and those both have been revised recently. They actually have not gotten as much enrollment as we expected, so I don't think we have plans for any more courses in those areas. We need to let those courses run for a while and see if they excite new interest in students. But we do have adjuncts with great background in those areas. So again, if you do want to explore further, talk to your mentor, and your mentor would need to talk to Diane Schickman, who has those contacts and probably set up at least one independent study in that area for the time being. And actually, as you request independent studies, those sometimes do become eventual courses because you express an interest, we find someone who's interested in doing that with you, and then maybe we expand it to a few students, and then it goes up to a course level. So certainly explore those possibilities, and we do have the context in order to help you explore GIS with more depth. Okay. And my next slide just is other areas and questions. And I don't know if the person who asked this is on here, but there was a question about degrees in technology. So let me talk about that a little bit, and then I'll give you time to think of more questions. The questions have been great, so please keep asking. In terms of technology, most students that we find who do degrees in technology with us come to us with technology background. It may be an associate's degree in a technology area that they then want to expand into technology management for their bachelor's degree. That's the one I've seen most often. There also, I saw an interest in, I talked about information systems. There's also information technology. We are offering a few more courses in that area, but again, you'd need to either augment that with either courses elsewhere or getting prior learning credit for what you may have in that area, plus maybe doing one or two independent studies. The guidelines for concentration technology are on page 90 in your guidebook, and they're quite open-ended, again, because technology degrees can cover a whole variety of things. But the current guidelines just say that you certainly do need, at least through intro calculus in mathematics, whatever physical or biological sciences would be connected with your technology area. Again, if it's information technology, probably not much, but if it has to do with technology and biology, then you certainly would have a lot of biology. Most technology degrees include some physics. A technology degree certainly would include some knowledge of computers, again, less for something maybe in the sciences, more for the information technology. And then, because it is a technology degree, some hands-on is important. We don't have, we have some hands-on segments, virtual labs in our courses, but again, most students coming for a technology degree with us probably have some lab experience. We do get technicians, so they're coming in already with that, and then so they'd incorporate that program in through their previous experience. And then economics and management principles if appropriate. So again, it would depend. This is leaning toward technology management. That certainly that degree would involve business courses. And there is a course being proposed in Technology Management. So that course will be available soon as a regular online course. But we do offer that as an independent study. We have someone available to do that with students. So if you're interested in Technology Management, you could certainly do that now. There are other areas that I could talk about, or, oh good, I see a hand raised. Okay. Yeah, so first fold is long. Okay, good. I don't know how I define low. It's more than we've seen in the past. I think it's a growing number of students who are doing math degrees, but probably any one term from 1 to 3 students who are taking abstract algebra or real analysis. So I'd say in terms of math degrees, the majority are probably doing the applied math degrees. Probably maybe around 10 students totally, just going by the numbers, who are doing that independent study right now, who are working toward a mathematics degree. Well, we're certainly not going to offer an online course in knot theory. But that's an interest in which I don't know if Sarah McAllister, who's our mathematician, would feel comfortable doing with you, but she also has a lot of contacts with mathematicians, so I'm sure we could find someone to do that with you. But that would most likely, for quite a number of years, be at the independent study level. In terms of probability, we do have a mathematical statistics course that gets into a little bit of the calculus-based probability. Don't yet have, I think, enough people to do the calculus-based probability, but again, we have people who could do that with you. So if you have an interest in that, as I said before, you know, let us know. I'd be the person, or Sarah McAllister, you'd contact, or your mentor would contact about that. We need a little bit of time to find a person to do that with you, and you know, if it worked out well, then we've made the first step toward it eventually becoming a course with us. That's a great question. So the important thing is, if you have those interests, talk to your mentor and try to set those up as, you know, at least a term ahead. It's not something you can say the day before, you know, the registration ends, oh, I want this course. You're not going to get it that quickly. But certainly a term ahead should be plenty of time for us to identify someone to work with you. And of course, you know, mathematicians love to do stuff like that, so so they'd be thrilled to have someone interested in investigating that with them. Okay, any other questions? And okay. Oh, that's a great question. A degree in any degree requires 45 advanced level credits. With 24 in the concentration. So yes, I would say that if you're doing a degree in mathematics, you need at least 24 advanced level credits in the math or applied math, depending on what you do. And the rest of them could be in that area or certainly could be general learning. So you just need the 45 total with the minimum of 24. But remember, I don't know your background, but there are some introductory level courses that you would need. Calculus 1 and 2 are intro level. And if you do need to do math, the pre-calc or in preparation for that, those would not count towards those 24. So that does get you around 30, 40 math credits. Also, the initial statistics course is intro level. So you're right, it is around 30, 40 credits, but not all at the advanced level. Great question again. And I did put on slide 1 my email. So do feel free to email me, and but most importantly, you know, this is a good entree into communication with your mentor. You know, either just initially, or if you're writing, planning, and finalizing right now. This is good information to incorporate into your work in that course. Okay, well, thank you for all your questions. That made it, I'm sure, a lot more interesting for all of us. And I appreciate your time and having the opportunity to talk with you. Oops. Whoa, who's the rock climber? Not that I know of. Well, first we have to find out who the rock climber is.
Exactly. Be interesting course to do online, though.
Yeah, right, really. Send me an email and remind me, and I'll find the rock climber, and at least, you know, if not an actual course, maybe we could work something out. Oh, well, thank you.
Okay, well, I guess if there's no other questions, we're going to end the session. This is Teresa, by the way, I will make sure that when the recording is received, I will send the recording to all of you. And thank you very much for your time, and you guys have a nice day.
Thank you. Oh,